Hello student, this could be the section to introduce you guys about the second chapters of the applies forecasting class, and in this session we will mainly learn about the time series plot and how we can represent everything in the data visualization for the time series data. And the thing I want to introduce you guys will be first of all the RStudio. If you already have a follow of my instruction about how to use RStudio, install them on your computer, I'm pretty sure that you guys already have it on the same interface like this one, and this will be the main like very brief introduction about how you guys can interact on the RStudio. So first of all, you can easily find that this would be the interface, and it has been divided into the four different kinds of like window. The first window, this will be what we call the coding or console the script window, so in which we can say we can create all our coding. Of course you can also write it here in the console window, which will be very familiar in other programming language, but I'm pretty want you guys to just just recommend you guys to use the R script window, because they really have a kind of like helpful. For example, when I really want to do for the function, they really give me the suggestion about the function that I'm using. For example, one of very important function that we going to do in this chapter will be autoplot, and you see I don't have to really complete the function, but it's to be called out for me automatically. So this would be one of the advantage of the using the R script when you put all your code in here. Another one, like I already mentioned about the console. So all the time that we run for the things that in the R script function, we will going to have it right in the console window. And if you really run it like in this one, so for some time they will just generate it and execute your function. Furthermore, sometime also when you go for some function and require for some kind of like display of the result, you can see over here they just not only execute for your code only, but also just returning to your result of the analysis. So that's the console window. Another one could be the environment window. That could be saves all your kind of action before. Also, that's the regress and just derives all the data, and it will be all saved here actually. And the last one, that will be the plus window. So basically sometimes they have a multi-function, and they provide a lot of things, like they provide the thing about the file, and also for the plot, when you really like generate for kind of like data visualization function over here in the R script and run it on console, so they will be saved here, and this will be our plot. If you feel it's not so good, you can jump it in, so it can be bigger and you can directly save it or copy it like whatever you want. But in other way, like you feel it's not comfortable, you can easily save it like an image or PDF file, so whatever you want, like they will be available. Okay, that could be the interface up there, the RStudio window. And now we talk about our kind of like libraries that we going to do in this section. So first of all, I just recommend you guys to install for the packet of fpp2 and the dependencies. So install the bucket, it would be the way for you to just install the same thing like the libraries in other kinds of programming language, and you just have to click on like install packet and then open for the parentheses and just say for what you want to do. fpp2 will be what we're gonna do, and brought this with this one, and you also put in for the syntax of dependency equal to true. That means when you install for the fpp2, they will also install for other dependent packet of the fpp2. So what exactly they are? fpp2 will be just kind of like a families of our libraries, and when you really use the fpp2 and you load it by the library function, so later they will be just not fpp2 only, but they will be a combination of the forecast. That will mean the forecast packet will provide all the forecast methods and some kinds of data sets we use in this course. Another one will be ggplot2. That will be a kind of super and impressive data visualization packet provided by Witham. And if you guys are the professor in data visualization, I'm pretty sure that you guys will have to work with this a lot of time. And the FMA, that should be data. That should be just a packet provided for the data only. But that could be has been derived from the book called The Forecasting Method and Application of Hitman in the 1998. So most of our data will be included here. And lastly will be this will be exponential smooth. That could be the data in another book that forecasting exponential smoothing up the Hitman 2 in the 2008. So that's the reason why I say when we really do it, we can say a lot of data and time too. So basically, if you really do it, you don't have to. The only thing that you have to install will be this one, and the way for you to run it, you can have the two way. First of all, to like put run. Another way, you choose the combination of the control and enter, like the same with other function, just for running for that. And actually, like for this packet, so because of fpp2 will come up with other kinds of packet dependent to it, so you don't have to really go out and call out for library of the ggplot2 or forecast, because they save here. So the thing will be like I just have to execute for the library of fpp2 for this function, and they will be always become out. Now this will be the thing you really want to do. We'll talk about our first practice, and in this section we'll talk about the time series object. The time series object will be the list of the number, and along with that you will get also the information about the time those number has been recorded in the data. And the time series, they quite complicated, and you will have to use the function ts, and over here I will just represent for you what exactly that mean in the first chapters. So for this one you will try to generate a time series, a time series, and I'm gonna do it just follow for this one. So y equal to tx, open for the parentheses, and you want to combine that means c that means that you want to combine for a list of the numbers. So like for example 100 and 300, like 225 and 650, and another one will be like 520, and another one I want to just generate from like for example from like 600 into 610, and that will be it. So this will be the list of my data. And another one I want to put into for the star mean this mean with star with the time stamp of star thing. So over here maybe I would just start it from like 1992, something like that, and it will start, and it's like smart enough to, for example over here we going to see like what will gonna happen. I already create for y, and now I use the XDR means the structure. We will go into find out for like the structures, figure it out, like check the structure of the data. access. Okay, so str of y, I want to see it what exactly they will be. So they will call this will be the time series from like 1 into 16 if you see over here, from 1992, because I started from 1990, yes, 1920, right, into the 1935. So that exactly like 16 years, and they start from like 100, 300, and something like that, until when I jump into, so the first one will be the my my five of them, right? Five of them will be like the thing that I already just create, and then I'm lazy and I create from like 600 into 610. So they jump from, they just make it like in a sequence from 600, 601 into 610 if you really want it. Just spend all the data, and you can easily find it. So this will be the data, and they generate for automatically for the 16 observation. You can see it. Another way you really want to see for all the data itself, so you can put in like view function. They in some way will be just generate in another like function, and they create for kind of a sheet, so you easily can see all the data. But this be more like useful for other kinds of like the data frame, but we will just stop like this way. Okay, and you see like this could be the function for the how you can create a time series by yourself. However, the thing will be more complicated. So in some kinds of other case, you will have the data. It just this will be the annual data, right? You see all the annual data from the 1920 into 1935, and the frequencies of that will be repeat in each year will be just one time. So actually, they still have here syntax called frequencies, and we just put like equal to 1, because in 1 year we just have a frequency at one time that's appear, right? And they're the same. However, sometime like for example this one, okay, I will put in the number from C, okay, and I want to put it like about I want to generate for the data from like 10 into 200. Okay, start from, no, it's too much. I just 100, I guess, maybe even more. Yeah, it's okay, 100, and it start from like 1980, and with the frequencies of the 12 year, I will put it like 4. So can you guess like what will be the time that have the frequency of 4 times a year? That's a quarter. So I create this one. Actually, I will be the way for me to create a quarterly data. Okay, start from 19, or maybe like Q1 of the 1980. Okay, so with this I will have to put it clear. Let's start from 1980, and from the first one. Okay, from the first one, that will be the first quarter. And you can see over here I generated all the data from the 10, 11 until like 100, and we're going to see like what exactly we have. I hope that we are going to have it enough. Now you can check for the structure now. The same thing, and we're going to do with the structure. Now the time series will be generated from like 1 into 91, right? From 10 into 100 with this color a gap of 1. So that's the reason why we have like 91 observation from the 1998 into 1980 into the 2010, and that's could be it. I will go and check it like one more time. Why? And you have the data here. Okay, so the first quarter of the first quarter, and then 1998 we have the first quarter, second quarter, into the fourth quarter, and that's repeat again and again until when it finished with the 100. That should be our last observation, and that's belong to the quarter 3 of the 2002. Okay, and this will be the way for you to generate for structures. Basically, the time series data will be more complicated than that. You generate for the data all the kind like the elements of the function will be the data itself and so on. So the frequencies, for the frequency, if that annual data you put in one, because that happened just one time 1 year. Quarterly data, that's 4. Of course we have 4 quarter, happen 4 times in year. Monthly, that's mean 12. Okay, and this other kinds of thing like daily, you have to put in like 7. Actually, like here's 7, they understand that that's mean daily data. Or you, if had time, put in like 365.25, that should be actually the real frequency of the day in a year. And the same thing with weeklies, hours, and half hour. Okay, for example, one more time I will generate for another data. Okay, let me check it, and I will create it's called like Z's, and I'm going to generate for weekly data if you want weekly data. Okay, and we will go and generate for the weekly data start from like week 3 of the 1999. Okay, and I just time series, and I create for the data from 1 into maybe not 1 but like 2 into the 100 with the frequency of like 2. Okay, let's this time we will check it like 2, and we start from, you can put it like frequency first or start first. So over here you can see easily that they will put frequency first and start later, but whatever you want. Okay, and the start example you will put in like which year and what quarters will be like this one. They will start from the second quarter, so just be careful with that and clarify it's very clear. So I put in like with the frequency. Okay, now I will put it like frequency first, and I put it in like 52.18, right? All the time that you not feel sure about that, just go back and see that this will be 52.18 for the weekly data. And I started from from like C up there 2001 and 2, for example, and I start from like with number 3. Okay, with number 3, and do it. Now I'm going to check it how it look like. That's could be called a time series start from 2000, and this will be start from like the first week of the years, and then it end with the 2003. So you go over here and you see the frequency would be the weeklies, and it start from here into 2010, and they generate like one time like this way. Okay, and that would be the point I want to talk about, the how you guys can generate for their time series, and be careful about that. Another thing we will quickly go and see in the next one will be the autoplot function in the fpp2. So all the time you put in like a time series like this one, you just not like come in with this. For example, I put in like not just z's but like y. Okay, and you can easily see this could be what you're gonna just generate on this graph. So they start from the start years, and they also have the level of the data. Okay, we're going to talk about that later in the next chapter. Okay guy, now continue. I will just show you how to load the data from your local computer. The thing will be like some of the students ask me like the data sets that are already generated by just myself and just randomly, right? So in case like without that, how can I collect lower data from my local computer from my that's been saved in my hard drive already, and how can I just import them into the data? So here I just recommend you guys to do the you get into the section 2.10, that should be the exercise, and this will be a perfect time for you to go with the exercise number 2 to download for the tube.1.csv. And when you already have the data, okay, like with me I have the data here, okay, and I copy it into my, for example, like this one, into my VNUK folder, into your section, and I put it into R and I save it here. Okay, so this could be very important for you to understand about how to click on and get the data. Okay, so I give you two ways for just generate everything in the same way. First of all, the way to just load the data. Now I will load the data. Okay, the data directly. So from the working from typical working directory. Okay, and how can I do it? So I had to remember about the location of the working directory I want to do it now. The data is being saved in my eDriver and another like in the subfolder. I just have to copy it all. Okay, and then go back here, and now this will be the time for me to use the function. So just remember the name of the data. This will be tools, right? This will be the tools one. Doc the CSV. This will be the end of the type of the data. So I choose and I would say call like the T1. Okay, this will be the data I want to call, and I read it. I will call the read.csv. Okay, you see over here the data. The function has been already subtracted for me, and I put in the open the parentheses and copy in the link of the data. Okay, this just the link of the directories, and remember you have to switch with the stack here. Okay, in the same function like this one, and now the name of the file, because in some way like you have a lot of data over here, so you have to put in like R. Okay, and that will be 2 1. Okay, .csv. Okay, and let's check it a little bit, like see what exactly they would look like. Okay, and you can see over here, okay, you can see over here the data. They have the header, that means they will be the label of all the data. We have the cell, we have the ads budget, that should be advertisement budget, and the GDPs of the Australia. I'm not sure about this one. The data according to the book will be about the quarterly sale of the small company over the periods of 1981 into the 2005. Okay, that should be the point. But let's come back into the data. Okay, now let's just read it as CSVs, and remember you have to put into header equal to true. That means the data will understand that the header, this one will be the name of the variable. Don't forget about that. Okay, now let's do it. We have the data of tube. Okay, and if you want to see SDR, okay, of the tube one, sorry, it should be tube. This is not the tube. So that's a data frame with 100 observation with 4 different kinds of variable. This will be the characteristic of the time frame and the sales and as purchased and the GDP. Now the thing will be like you will have to convert your data into a time series, and how you gonna do it? This will be the time for you to convert the data into a time series. Okay, remember about the TS, alright? I will still put it like to 1, okay? Maybe like TS, okay, maybe TS. That's mean to 1 in the time series frame, and I put in TX. And remember about the data. Okay, so I got the data I want to use it, like I already have this is in tube 1. The thing will be like for the sale, I'm good with that number, advertisement budget and GDP, they are number, but I don't want to include for the first one. This is characteristic, they don't understand this is the march of 1981. No, they just the characteristic, so they don't understand that this is a time series. I would have to remove it, and the way for me to remove it would be like there's some way. The first way, according to the book, that I will say, I will tick in a comma and then -1. Why it is -1? I will show you why. Okay, so the tip one, this look like this, right? It look like this. With the first, this will be the X. This will be all for this one because they're missing, so they will just defaultly put it into X. And then sale column and advertisement budgets and GDPs. But now I don't want to use for the X variable because they are meaningless with me. So I can in some way just select it by there are two things that between the comma. For this one, that should be the index of the row. Okay. So if you put in like the first row, okay, you can see like they will collect all the data, and you give it blank in the second. So that means this will be for row, this will be for column, and you just want to have the data of the column, the row 1, but you gonna get all the data of the column. So that's the reason why you get it here. In another way, if I just get it like 1 in this side, now you just have the data of the X. That means the characteristic about the time, right? Or like I put it like 2. Okay, you see all the data about the the cell, right? The cell. Okay, so that's the reason why if I just choose like -1, I can do it the same, right? Like 3, that means I would just select all the data of the third column, the same thing, and I can make the combination. I want to have the data from 2 into 4. That means I want to have all the data from the column 2 into column 4, not column 1. Okay, and I put it, and you can see over here all the data has been included except for the time frame. Okay, now it's the same if I do it like tip 1, but I collect it with the -1. You can easily understand that I'm selecting all the data, but not the first one of the first column. Okay, so that's the reason why here it's put into the data like this. And of course, with the time series, let's come back with the time series stem. So it had to start from 1981, right? Because they say that will be from 1981. Okay, and that stopped in 2005, but they will just smartly just generate it until 2005. You don't have to worry because the data already really has covered into the 2005, and we put in the frequency. Don't forget about that. Frequency equal to 4 times in year, because this is quarterly data, and you got it. Okay, now take a look into that TS. Is that different? Yeah, they are a little different now. That has been generated for the time frame, and especially they had their years and the quarter exactly of the data that's be recorded into. Okay, now let's construct for the time series plot. That should be actually for the function of the autoplot 2, but we do it right now. Okay, and you put in like autoplot of the my time series will be tip 1. Okay, TX, and I put in phases. Okay, faces equal to true. Okay. Oh, I'm sorry. I still have it here. Okay. And this will mean this mean I'm generating a time series plot on the data. Okay, with faces. Okay, now let's just do it, and we compare it with the another function. So this will be the graph. You can see like sale as purchased and also GDP has been generated for the different kinds of what, the different kinds of I mean the separated, already separated the graph, like they have the different for the x-axis, right? This is a different graph, this different graph, it's different graph, and they have the different x-axis values. But however, they challenge for the faces, but they keep the same with the time frame in the x or the horizontal axis. That's the reason why. We can also just try it with another plot. I do it with the auto. Okay, plot, and we put it like tip 1 ts2, but this time now the faces I will put in like 4. Okay, equal to, I'm sorry, that's missing something. Okay, 4. Okay, or you don't put anything. This could be the point. All the data will be included in the same graph. They don't have the separation between the graph, and this is very lucky when the cell they normally is around like about 1,000 to 800, right? 800 to 1,000. While the ash budgets they are in the different value frame from like around 600, and the GDP is very low. But that's very lucky in case like everything input in the same plot, they will be overlapping with other. That will be a more problem we have to see. Okay, and this will be the first part of the section, and you already know how to just first of all create for the time series, and also just input for your data. Okay, input for your data. Okay, now